Good morning, boys and girls. We're going to continue our study of data and probability. We are nearing the end of the chapter, so this is really the last lesson that we'll have in this chapter. We've talked about the different kinds of graphs that you could have. You could have a circle graph, you could have a bar graph, you could have a pictograph, you could have a line graph, you could have a line plot. Okay? And we also talked about probability. What's the likelihood that some event was going to occur? Maybe that event was I'm going to roll a 3 on a dice. Maybe that event was I'm going to put my hand in a bag of marbles and pull out a blue marble. Maybe that data was I'm going to spin a spinner and it's going to land on blue. Okay, well, what you're going to do, and we learned how to graph the information from those predictions too, but what we're going to learn today is how we can look at that graph data and make a prediction about what's going to happen next. Okay, so I'm going to turn my camera around now and we're going to look at a line plot graph. Okay, now on this particular line graph, what happened was a science teacher in third grade took the daily temperature, which meant like she went out at 9 o'clock every morning and took a temperature reading of what the temperature outside was for 21 days, and she recorded her information. And she recorded it on a line plot like this. So what the teacher noticed was when she was taking this temperature, the temperature seemed to not, on the days she took it, the temperature was never lower than 65 degrees and it was never higher than 75 degrees. So when she made her line plot, she didn't have to make a line plot that started at 0. She could just use a piece of the line, which we know every time we look at a number line, we're looking at a piece of a line because it goes off in both directions forever and ever. So we can never actually see the entire line. So there's nothing saying that we can't just look at the number line between two sets of numbers at a specific piece of the line. And in this case, it's in our best interest to look at the piece of the line that goes between our lowest temperature of 65 degrees and the highest recorded temperature of 75 degrees. Now, because there's only a few numbers in between 65 and 75, we can show all the different numbers on the line chart plot. What I did do in this particular one, just to make it easier to read, was because my space was limited and I didn't have a lot of room, was I wrote the numbers on two different levels so that the one next to it was a little higher or lower than the number before it, so that you could read it more easily. Because remember, if you can't read a graph easily, there's no point in creating it. Okay, so this is the way the data fell when the science teacher took all the temperatures. There was one day that had 65 degrees, there was two that had 66, one day had 67, two 68, 169, and so on throughout the chart. Every X indicates one day with that temperature. Okay, so now that this line plot was created, the science teacher asked her students to make a prediction about what the next day's temperature might be like. Now, she doesn't mean necessarily an exact number. She means about what temperature do you think it would be? Because even the weatherman can't predict exactly what the temperature is going to be. But what she asked them then, instead of an exact number, was, well, do you think the temperature will be in the 60s? Or do you think the temperature will be in the 70s on day 22 of taking the daily temperature? So, how can they go about figuring that out? How can they make a prediction about whether the 22nd day is going to be a temperature that's in the 60s or in the 70s based on the data that they have already collected? Well, what they can do is they can look at their line plot here and you can look at the temperatures that are in the 60s and you can count them up. And then you can look at the temperatures that are in the 70s and you can count them up. And then if one of them has a good deal more than the other, then it's more likely, based on the history of the data we've collected, that the next time you record a temperature, it too will be in this with the same number, the group that has the largest number. So let's do that right now. Count how many days are in the 60s. So I'm going to get you closer so you can see the whole part with the 60s. How many X's are falling on the side of the number line where the temperature is in the 60s? Count them now. Okay, I counted 7 days that had temperatures in the 60s. 165, 2 more at 66, that's 3. 1 at 67, that's 4. 2 at 68 degrees, which is 2, 4, 6. And 1 at 69 degrees, so 7. Now, let's count how many days had a temperature in the 70s. 2 and 3 is 5. And 3 is 8, and 2 is 10, and 3 is 13, and 1 is 14. So we've got 14, and we've got 7. 7 days of our record keeping has shown us that the temperature is in the 60s, but 14 days, the temperature was in the 70s. So we can make a prediction that since more of these days have fallen in the 70s, then probably the next day would also fall in the 70s. Now, it might not be. It's just a prediction. And remember, predictions are not always correct. They are just an educated guess based on what you already know. When we're in science, we call that a hypothesis. In math, we're calling it a prediction. Okay? All right. So, since more of those X's were on the 70s side, we probably would make a prediction that the next day would be also in the 70s. Now, let's look at this bag of tiles. If you were to stick your hand into this bag of tiles and not look, just pick a random tile out of there, we want to make certain predictions about, well, let's figure out what the probability is of picking out each tile. So if we were going to put our hand in, what would the probability be of picking a red tile? Well, the first thing you have to do is you have to figure out how many tiles we have all together. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 tiles. So let's start with red. If I was going to stick my hand in this bag without looking, what is the probability that I'm going to pick one of these red tiles here? Well, if you said 5 out of 8, you are correct. What's the probability that I would pick a blue tile? Right, 1 out of 8. What's the probability that I pick a green tile? Right, 1 out of 8. And what is the probability of me picking an orange tile? 1 out of 8. Good. So now, if we were to pick a colored tile from this big bag that is shown right here, what color am I more likely to pick than any other color? So in order to make that kind of prediction from a probability experiment, we first need to find the probability for each one, which we just did. All of them have 1 out of 8 except for red that had 5 out of 8. So since there are more red tiles than any of the other colors combined, you can predict that you're more likely to pick a red tile. Just because there's enough, there's more of them there, your hand is more likely to land on one of the ones that had 5 of that color rather than any of the others. The orange only has 1, the green only has 1, the blue only has 1. But there are 5 red tiles in there. So just based on this information or this information, which is what we just figured out, because red has the highest probability of occurring, my prediction would be I'm probably going to pick a red tile out of that bunch. Does that mean it's absolutely going to happen? No, I could still pick an orange or a green or a blue, but I'm more likely. So my prediction is going to be what's more likely. Just like with the line plot up here, my prediction is that it's more likely to be a day in the 70s than in the 60s. Okay, so remember, I'm going to turn this back around so you're looking at me again. Remember, a prediction is just making an educated guess based on what you already know. So we're going to make a prediction. Predictions don't always come true. Sometimes they do, because sometimes the data that you have is so reliable that you can really get a good handle on what the prediction is going to be. But sometimes it's not. Okay? Alrighty.